Welcome to the Retro Hack Shack. I'm Aaron Newcomb. Today's episode is part 2 of a 2-part series where I'm trying to build an adapter to get high quality output from retro computers to devices like VGA or HDMI, specifically HDMI, capable devices, because that's what we have around right now. In part 1, I took a look at the various options and I started soldering together the solution. If you want to check out that episode, you can just hit the link above and you'll be directed there. I highly recommend you watch that first because this is really a continuance of that. So in today's episode, I'm going to be putting together the cable that will connect the board to IBM PC 5150 or similar type device. And then I'm going to be hopefully testing the output from the IBM PC, both in CGA and EGA modes. And I also want to check out and see if this will support a Tandy 1000, which had a little bit different color output. It also has CGA mode, but 16 colors in CGA mode. Can I get it working? Well, let's find out right now on the Retro Hack Shack. Okay, so I'm starting to make up the cable, which is going to connect to, in this case, a 5150 or anything that puts out standard PC, CGA, EGA, MDA graphics, right? So what I've done is I've started constructing this cable. Now, in one of my first videos, in fact, it might have been my first video on the channel, I'll put a link up above if you want to reference it. I was making a cable with this type of ribbon cable for a floppy drive connection, and I was having a really hard time getting this press fit connection to work. And some of the suggestions that people said in the comments were to either use a vise or use a clamp. So I've got a clamp here, and I'm going to see if I can get this to press down evenly. The reason you don't want to use pliers is because pliers, the jaws of pliers, I can't really show it that way. The jaws of pliers don't come down evenly on both sides, right? Because they're a V shape. So when it comes down, it puts more pressure on one side or the other. That can break the plastic or not make a good connection on one side. So you want something with even force. I do have a vise, but it's down at the makerspace right now. So I'm just going to use this this little 2-inch clamp and see if I can get this to go together evenly. Let's see if I can do this on camera. Let me zoom in a little bit. There we go, back in frame. Let's see. There we go. Almost there. I heard one side snap. And I think they're both in there. And, you know, notice the plastic's not deformed. Nothing's bent out of shape. I think that works pretty good for a little connector. For a bigger connector, definitely a longer vise would be better. All right, with that end clipped on, it's time to connect the other end of the cable to the connection that's going to go into the PC in this case. I made up this little chart with EGA Pinout because I want to be able to use this. This should be compatible, like I said, with MDA, CGA, and EGA. The pinout should be compatible. So I just got EGA because that has all of the most selection of the various signals that I need, the fullest, I guess. And I'm just using this DB9 with this little housing on here that I'll put on at the end. And I've also mapped out the way this cable actually connects to the computer. So I've toned this out with my multimeter in continuity mode. And I've labeled where each one of these cables goes, or what each one of these cables is connected to on the board. So now it's just a matter of matching up, for example, 0 volts. I didn't want to put ground there because there's 2 other G's on here. So 0 volts is ground. Match up ground with the ground connector on the EGA pinout here for this connector. One thing to note here is that there's 5 volts on the board, which is needed for, I believe, the BBC Micro, which is what this adapter converter board was originally designed for, but then it was broadened to be used by other systems. So we're definitely not going to need 5 volts. So that I will cut off, and we won't use that cable. But all the other ones you can see here, there's little g, little r, little b, and then big R, big G, big B. That's primary and secondary colors. So with EGA, there's more colors represented, so there's more color signals, and they split them up into primary and secondary. So the little ones here represent secondary, the big ones represent primary, and then of course we have horizontal sync and vertical sync as well. So I'm just going to go through and solder this up, and should be, I think, ready to test this out. So before we can use the board, we just have to install the software. I will say the documentation on the wiki page is extremely detailed and well thought out. It's super nice to have this level of documentation available for a project like this. But you just go to the quick start guide, download the latest code, follow the instructions. Essentially, you just copy the files over to an SD card and then stick that card in the Pi. The first time you boot it up, you'll get a menu that looks like this because the CPLD is still not been programmed. Luckily, they've included the ability to upload the code to the CPLD right from the Raspberry Pi itself when you boot it up. So you just select the proper option for the board that you built, hit the button, and it will upload the code for you. Programming is done. No need for a separate programming interface to program that CPLD. Very nice. Okay, so it's time to test out this board. So I've got it hooked up to the 5150. So the first thing to do is turn on my battery pack, which is powering this thing. And we should see the board kind of boot up. There it goes. Nice. So it detected looks like it detected the LCD TV automatically with 1440 by 900 resolution, which is the max that this particular display can do. So I believe it's using EDID to do that. So well, I shouldn't say any, EDID works, 95% of the time or so. There may be a few cases where it doesn't work, but at least it will detect the resolution on your monitor. Hopefully I've got the autofocus or the manual focus set up right on the camera so we can see this as we go through. So now I'm gonna go ahead and turn on the 5150, and within a couple seconds we should see a blinking cursor if this is working. Oh, I do see a blinking cursor, but it's looks like it's out of sync or something because it's kind of jumping around. Let's go ahead and let this boot up and see what happens. Now I've got this connected kind of precariously in the back for now because I just want to test it. I didn't want to go ahead and 3D print a case and finish the project all the way up without seeing if it was actually going to work. So I just kind of have it dangling there in the back, and I'm going to have to reach around if I need to use the buttons on the board to fix some of this problem. But this is a good sign. At least we're seeing a cursor, which is what you would expect to see on a normal boot up of a 5150. That's good. Okay, there we go. Okay, well, I can see it. It got a little brighter as it was going, so I'm assuming there's some sort of auto correction going on, but it still has this sync problem. So let me go into the settings of the board and see if we can fix this. Okay, there's the menu, so that's good. Okay, so here's the problem. Here's the nice thing about this board is, as I mentioned before, hopefully you can use this with all sorts of different machines. And I guess by default, it's coming up here set up for an Acorn Electron, which this is not. So it's got a bunch of these profiles built in. So let's go down and change the profile to PC and see if that helps this, this problem that we've got here. Scroll down. And you can see some of the various, as I go through here, this is the Amiga profile, Aquarius, all kinds of profiles, Atari ST. It's not going to work for every system, but there's just a ton of profiles in here. There's some color tests, Commodore 128, which actually doesn't look that bad. At least it's not scrolling anymore. The signals should be similar between a PC and a Commodore 128 in 80 column mode. Custom, Olivetti, Oric. Come on, where's PC? Okay, here we go. Standard PC. That looks good. Okay, let me get out of this menu. Whoops, let me get out of this menu and take a look. Wow. Okay, hopefully this focus is working on the camera because this looks really good. I can clearly see on the M, I can see the whole M. I can see all the characters down to the pixel almost, which is awesome. So it doesn't look blurred. Now, actually, if you were looking at this on a CRT because of the quality, it probably wouldn't look this good. So just by looking at this, you can tell that it's digitized. But otherwise, I mean, that looks really, really good. Wow. Now let's go ahead and start up a game and see what it looks like there. Ooh. Okay, that's not bad, but there's this wavy lines, which is kind of weird. That's not good. I was hoping this would work out of the box. Maybe there's some adjustments I need to do. Let me go back into the settings and see if I can adjust this to make the picture a little bit better. Okay, I've paused the game just so that the sound doesn't get in the way, so you can hear what I'm saying. But you can still see the wavy lines, but here's what I found actually. If I go into the menu, you can go to, there's a setting in here called auto calibrate. And you can do this while as long as the screen is stable, it's not moving around. So you do need to pause a game like this if you're having this issue. And then you can hit auto calibrate, and it makes you press it again to confirm. And it's going to run through some things. And it changed the sampling phase here. It's going through testing out these sampling phases. I'm not a video expert. I don't know what that is, but it looks like it changed it to 2. And it does look like it has fixed the wavy lines. I'm just going to save this configuration before I get out of here. And let's return. Okay. So now, wow, that looks really good. You can see that the waviness has disappeared, and the game actually looks just as you would expect it to. Whoops. There we go. The game looks just as you would expect it to, with cats running around. Here, I'm going to play a little bit. Why not? Oops. This is hard to do with a keyboard. I'm awful at this game. Let's try again. Ah, I fell off. Okay, so anyway, this is looking great. This is better than I expected. Everything's looking crisp, sharp, but not stretched out or blurry. Everything looks, the scaling of the pixels looks exactly right now that I've gotten rid of that waviness. So let's just fire up another game real quick and test that out. Let's test out some Bruce Lee karate. Oh, that looks great. Here we go. One player versus computer. And let's go with joystick mode. I think I have to calibrate. Yep. Rightmost, leftmost, topmost, and bottommost. Player 1. Here we go. Ooh. See if we can punch. Yeah, this is looking really good. Get out of here. Joystick's not quite calibrated exactly. Yep. Yeah, looks good. So this is great. I don't see any, the other thing I wanted to test for, can I pause this? Yeah. The other thing I wanted to test for is if I noticed any delay, right, in the video, any lag or anything like that, and I don't notice any at all. So this is a really good indication that this is working just fine. Hopefully it's coming across on the video. This looks very sharp, very crisp, very nice. I'm really happy with it, that it's working. I do want to test it out on an EGA card and maybe pull out my Tandy 1000 and see if it works on that. So let's go ahead and see if I can stick an EGA card in here and see if we get EGA graphics via HDMI to this LCD TV. Before I do that, I do want to check the color palette. I'm going to use Check It for this. There's other programs that show you the various modes and palettes you can check, but I'm just going to use Check It because I happen to have it here locally on the C drive. There we go. Check it. Even that looks very crisp and nice. And if we go to tests, we can go to the video test. I just want to do the graphics test because that should test the modes. There's mode 04H, looks good. Mode 05H also looks fine. And this is mode 6H. I don't remember what all these modes are, but I think this is the higher resolution 2-color mode. And here's the color palette. Here's what I wanted to see. So yeah, we should be seeing green, red. Oh, it's going too fast. Cyan, magenta, light gray. Yep. Yep, all of those look good. Cyan, magenta, white, these look perfect. So is the display correct? Yes, it is. And now we're just going through some color purity. So I guess I'm guessing here that on a CRT, if you had some bleed or something like that, the color wouldn't be uniform across the screen. But yeah, this is really just testing for me, it's just taking a look at the colors and making sure that they look decent, which they do. They all look great. So there we go. So that looks really, really good. Okay, now let's see if we can get EGA working. Okay, for this test, I'm going to be using this Expert GEGA 480 card. I couldn't find any manuals or anything online. Somebody gave this to me to test out. So I'm going to try it. I do have the matching utility disk, or it's actually not matching. It's this one. It actually goes to a different card, the GEGA 350, but the utilities probably work for both. So I'm going to try this card out. I don't know the jumper settings there on the edge. I don't know how to set them. I referenced some other video cards, so hopefully these are set for enhanced EGA mode. I don't know, but I figure I might as well try it out. Okay, so I've got the EGA card in. Let's hope the jumper settings are correct. The adapter is on. Let's turn it on. Okay, so that's the those beeps that you heard is the 5150. When it goes through its testing, it's telling me that there's a custom BIOS error, that there's some error. There's a custom BIOS that runs on this card. I can see some blinking text here. So that's kind of interesting. Let's see. Maybe we need to adjust modes. Yep, we're in CGA mode. Is there an EGA mode? There's MDA, Hercules, Hercules text, Hercules graphics, EGA. What does that look like? Ah, okay. Looks good. I can see the BIOS. And we are booting. Okay, there we go. It's finished booting, and now I think what I'll do first is take a look at this utility disk and see if there's a utility that tests the EGA graphics, so we can see what it looks like. Unfortunately, there's no testing here to be able to test it. So let's instead try out a different utility. Okay, so a couple of things. Number one, I forgot to flip the dip switches inside the 5150 to enable the EGA card to work properly. So I've done that now. And I think I've also found a proper utility. Let's go ahead and turn this back on. The other thing I've also done is I've hooked up my external GoTech floppy drive because I found some EGA utilities that run on a disk image and I want to try them out. and I didn't have time to actually write a proper floppy disk, so I just hooked up the Gotek, which is exactly why I made the Gotek external in the first place. You can take a look at that video if you want to see how I did that at the link above. Boot it up. Let's go ahead and check out the utility I found. There's actually quite a few things on here. The one I want to run is this EGAD, EGA Diagnostics is what I assume it stands for, but I like how it's called EGAD. And here we go. This was written by David Morrill. David, if you're still out there, thanks for putting this together. It does look pretty sharp so far, but it's only black and white. So let's just check out the colors. Ooh, nice. So you can see they're all 16 colors, and it looks like you can actually edit these. You can go in and edit those colors if you want to test different shades. So that's pretty cool. Let's check out variations on those colors. There we go. Nice. All 16 EGA colors look great. And you can see the various shadings. Oh, this is a really cool program. So this is all colors with dithering. Let's quit out of this. I think he's also got some demos in here. So there's one called Dandy Doodler. Interesting images. What's interesting images? I hope that's not what I think it is. Oh, no, it's okay so far. So it just puts a bunch of different images, but it does demonstrate the performance and the quality of the EGA graphics. Let's do another demo. Let's do this Dandy Doodler. Okay, so that's pretty cool. So it's painting all the different EGA colors with different shapes, it looks like. Can I change this? Oh, yeah. Cool. Cusp. Yeah, so you can have all kinds of different shapes. That's pretty neat. And then you can go down and do fill. Let's change that. Oh yeah, random. Oh, that's really cool. Yeah, this is a great demo program. If you're looking, I will try to put this image out on my website when we're done, retrohackshack.com, retrohackshack.com, and you can download this if you want to test out your EGA graphics. Very cool. Okay, let's try a game. So here's an example of Arkanoid. Many of these games that came out gave you the capability of switching between CGA, EGA, or Tandy modes. This one does. Never mind the words down there. But I'm in CGA mode now, so let's try that out and see what that looks like. Sure, we'll use a joystick. Oh, I'm going to calibrate. Okay, so here's Arkanoid. Can I skip this? Yeah. Okay, now let's switch to EGA. Okay, now let's try EGA. Much better. That's the difference right there. Wow. You can see the difference is pretty dramatic. And here's some actual play. This isn't bad on a joystick, actually. Huh. All right, well, I would consider this a success. The EGA looks great, CGA looks great, so I'll definitely be able to make use of this. In fact, I'm going to leave the EGA card in here and just play around with some of the games I've been testing that are EGA only. It should be a lot of fun. Okay, so I've moved down to the other end of the ping pong table and set up the Tandy 1000 TL. And the reason I did that was because I want to test this on the Tandy since it puts out 16 colors in CGA mode. Now, I did talk to the developers of the board. They said they think it might work, but they didn't have a Tandy to test with. So I'm happy to do that testing for them, and then I can give them the results if they're interested in if it works or not. So let's turn this on. You'll notice that the Tandy boots up 100 times quicker than the old 5150 because it doesn't do all those self-tests that the 5150 does. So let's go ahead and boot this up. Test it first on the CRT, and then I'll come back and test it on the HDMI monitor. And I do have a problem with the keyboard here, but let's see if we can work around that. So since I showed Arkanoid on the other system, let's see if I can get Arkanoid running here. There it is. And because of the glare in the room right now, I've had to record this from an angle. Hopefully that doesn't impact the ability to view the graphics. And you'll notice it pops up a menu. It automatically detects that this is a Tandy system, so it highlights Tandy, but you can see it's the same menu, CGA, EGA, or Tandy. And I don't have a joystick. So there's there's that opening screen. And there's the menu. Looks pretty good. For 16, it's really just the fact that it's 16 colors. I mean, it's still CGA, so the resolution is not quite as good as EGA, but it does work. And it looks almost as good as the EGA version. Okay, now let's, for another demo, quick demo, let's go ahead and try Prince of Persia, because that had some nice colors on the opening screen, I believe. This is a demo version that was written. I don't know if it was written specifically for the Tandy or just a general IBM compatible demo. There we go. Don't know if you can hear. I've got the volume turned down a little bit. Let's turn it up. Prince of Persia. You can get a good mix of colors there. You can see, blues, along with the oranges and the white. So pretty nice. There's the opening screen. It's gonna go through. Let's see if we can skip this and just get to the gameplay. Okay, so here's the... Come on, jump, jump. I didn't really play this game much as a kid, so... but you can see it looks pretty good with the 16 colors. Okay, so let's go ahead and fire up the other adapter and see if we can get this working through HDMI and compare the differences. Okay, I've switched over to the LCD monitor or TV with HDMI, and let's see if we get anything on the screen. Yep. Looks great. Looks really good. That's a good sign. Let's go ahead and fire up Arkanoid and see what it looks like in comparison. Notice it does get dim when there's not much on the screen. I don't know if that's built into the software that's running on the adapter. I assume it is, but it should get brighter as soon as we get a graphic. And it did recognize Tandy mode, so that's good. Of course it will, because all it sees is the equipment inside the computer. It doesn't know what monitor we have attached. And we'll go with keyboard. Okay, that looks pretty good. I think that's a winner chicken dinner right there. It seems to be recognizing all of the colors, no problem. And there's the demo mode. I mean, I would say that looks better, obviously, than the actual CRT. You can make out, of course, all the pixels here in the graphics, because of the sharpness of it. It's so sharp and looks so good. So yeah, I don't think there's any problem with the Tandy 1000 using this adapter. So that's really good news. Let's just try Prince of Persia to compare that real quick. While this is loading, I'll just point out that what I did was I made a separate profile for the Tandy 1000. I just copied the CGA, the standard PC CGA profile over to it. So far, I haven't changed anything. So what that means is you could just use the standard PC CGA setting if you want to build one of these yourself, and you don't have to create a new profile. It doesn't look like you have to change anything. The same exact setup that I had for CGA on the 5150 is actually working here on the Tandy 1000. Here we go. Loading screen. Looking good. So, I mean, hopefully you can tell, I mean, this looks, from a color perspective, this looks exactly like it did on the actual monitor. Of course, we're on a flat screen, things are clearer, brighter, etc. But this looks really, really good. "60 minutes left." Oh, I gotta do up. There we go. Oh, yeah. Looks really good. There we go. Yep, I think I'll call this a win. Well, I am really impressed with what this little device can do. It's got so many different profiles for so many different systems. It doesn't work with everything, but just the ingenuity that went into this, the fact that it's reasonable, it doesn't cost that much to put together. I think my total cost for this, if I include the Raspberry Pi, the cables, all of the parts, was still less than $50, which is pretty crazy. And the fact that it works so well and it's configurable, you can actually go in and change the settings for your particular system, or if something doesn't quite line up, you can go in and tweak things just a little bit to match your particular system or the way your particular system is performing on that given day. So really, really impressed. I'd highly recommend it. It may not be for everyone. I think they are looking at putting this into more of a retail package that you could just purchase, so you don't have to build it yourself. So that'll be great for those people that don't like to solder, especially the SMD soldering can be a little difficult. But I'll tell you what, for the price, this is worth every penny. I'm going to be building a few more of these. I'm going to be building, there's an analog board so that you can connect to like an Apple II or different composite devices. So I'm going to be building that next so that I can just have that in my arsenal when I want to capture some video from an old system through HDMI capture. The other thing that this is great for is, I'm thinking that if there's an old monitor, for example, that I can't restore, but the look of it is something special and it goes with a particular system, I might be able to use this and put a flat panel display inside with HDMI input and kind of bring it back to life. It still wouldn't have the glass, it wouldn't look exactly the same, but the shell would be the same. And it would look pretty close with the quality that this puts out. So that's one thing I'm thinking. The other thing that I'm thinking you could do with this is actually put it inside, because it's so small. You could put this inside of something that had enough room, like a Commodore 64, although that one's a little difficult to implement. Maybe an Apple device or something like that. You could actually put this inside and put a little slot in the side of the case for the HDMI. and then you'd have the option of doing, whatever RF out or whatever that system came with, and HDMI out of the back of the device. That would be pretty cool too. And because it's so small, I can see somebody mounting this inside of their actual machine and having HDMI out directly to a TV or something. That would be pretty cool as well. So I'm going to be building some more of these. They're very, very cool devices. I don't think there's anything better that I've seen on the market for this particular price point. So if you're interested, there'll be links in the description below where you can find out more information. If you like this episode, or if you've been watching for a while and you haven't subscribed yet, please subscribe. If you like this video, hit the like button. And if you want to support the channel, still looking for some folks to join the Patreon page where I'm collecting support to buy more things for the channel, more devices to hack on, better camera equipment, et cetera, et cetera. In return, you get some great perks. So go check out my Patreon page and please sign up. It would really help support the channel. So with that, thanks for watching. We'll see you next time.